Good morning, this is your Stat Sensei, Mr. Spensei, and this is 3.8.7 creating contingency tables, and we're going to do scenarios 1 through 3. So, when you go to create a contingency table, one of the most important things is to be able to identify the variables being compared. So, HEB purchases salmon fillets from only two distributors, one in Alaska and the other in Chile. The distribution of salmon fillets from Alaska with a mean length of 21.3 inches. A randomly selected fillet that comes from Alaska has a probability of 0.325 of being greater than 21.3 inches. The distributor from Chile salmon fillets have a probability of 0.358 of the probability of being less than 21.3. And 68% of the salmon fillets are provided by the distributor from Chile, and the rest are from Alaska. Create a table for the situation. So this sentence here, by the way, is in error and should not be included. So when we look at this, it looks like what we have is location. So we have a location variable, and it can be either Alaska or Chile. And then we have a size variable, and our size variable can be less than 21.3 or greater than 21.3. So those look like our two variables. Now let's read it again. And what we need to do is we need to find the one that's only deals with particularly one variable, not two. So we're going to read this really carefully. So a randomly selected fillet that comes from Alaska has a probability of 0.325 of being greater than 21.3 inches. So in this case, comes from Alaska, 0.325 of being greater than 21.3. So this one, that value is used for two different variables because it's coming from Alaska and it has to be greater than 21.3. So that has two variables. So that's not going to work. We're looking for a number that's only associated with one variable. The distributor from Chile salmon fillets have a 0.358 probability of being less than 21.3. Well, when I read this, it's coming from Chile. There's my value, but it's coming from Chile, and it's less than 21.3. So once again, two variables. The last number that we have, the third number, is 68% of the salmon fillets are provided by the distributor from Chile, and the rest are from Alaska. Does this say this one doesn't have anything to do with size? It only has to do with location. And because it only deals with one variable, which is location, then that's where we start. So we're going to start with location. And we said, oh, this is 68% from Chile. So I'm going to go ahead and write 68% as 0.68. And guess what? I'm going to go ahead and do the hard part. I'll write down this is a one hole. But this is from Chile, so I need to put this label up there. Well, if this is 68%, then this is going to be 1 minus 0.68, which is 0.32. Okay, so we have that part. Next thing, well, if this is Chile, means this is Alaska. And then we're going to do our size variable. And it really doesn't matter whether you do greater than or less than. I'm just going to do greater than 21.3. And then I'm going to do less than 21.3. I could have swapped them. It wouldn't have mattered. That's fine. So let's look at this. Comes from Alaska and has a probability of 0.325 of being greater. Oh, Alaska greater. That means this value right here is 0.325. But before I go any farther, there's something I need to do that's really important. I take these values. Once I have them, I go ahead and write them down. So I'm going to go ahead and write 0.68, and I'm going to write it really small. And this is 0.68, and I'm going to write it really small. And this is 0.32, and this is 0.32. All I did was bring the values up. Okay? Now that I brought those values up, I go, oh, comes from Alaska and has a probability of 0.325 of being greater than 21.3. So Alaska greater than, that means this value right here is going to go right here. So this is 0.325. Well, if this is 0.325, this is going to be 1 minus 0.325. So from that point, 0.32 times 0.325 gives me a value of 0.104. And this one is 0.32 parenthesis 1 minus 0.325. And this gives me a value of 0.216. Now, we know that we should be able to add these two values, so let's do that. Enter plus, and we get 0.32. So good chance we did that part right, because this plus this has to equal this. Okay, so we've taken care of this value. We've taken care of the 68%. We still have this 0.358. The distributor from Chile salmon fillets have a probability of 0.358 of being less than. So they're telling us, oh, this is on the less than side. So this value right here, this 0.358, is going to go right there. Well, if this is 0.358, guess what? This is going to be 1 minus 0.358. So here we go. We're going to multiply these out. 0.68 parenthesis 1 minus 0.358. And we get 0.43656. And I'm going to go ahead and take this out to 5 decimal places because it's going to help me with my accuracy. And then we have 0.68 times 0.358. And we have 0.24344. Oh, I should have put those in blue. Oh, well. So this is going to be 0.24344. Let's add these two values up. 0.435656 plus 0.24344. And if we did everything right, it's going to add up to 0.68. So I have something in error. Oh, I wrote this incorrectly. There's not a 5 there. So 0.43656 plus 0.24344. There we go, 0.68. So there's my values. Now I should be able to add these two values to get this. So let's do that. 0.43656 plus 0.104. And I get 0.54056. And I should be able to get add these two values to equal this. 0.24344 plus 0.216. And I get 0.45944. Adding those two values together, we should get one whole, and we do. So chances are we did this correctly. So that's the way you do the first table. Okay, the second one, once again, we got to read this and identify what are variables. The land of Nod is populated by all sorts of interesting creatures. Among them is the goblin. In order to attract mates, goblins slobber sometimes as much as a gallon a day. This trait is embedded in the genetic makeup of the goblin, and the gene is carried by both male and female goblins. 95% of the little goblins carry the slobbering gene. So we have a value there. So we're going to circle it because we know 95% of the goblins carry the slobbering gene. If the little biological mother carries the gene. So here we looks like we're saying, okay, the little goblins carry 95% carry it if the mother carries it. In addition, it's known that 85% of adult females carry the slobbering gene in the land of Nod. In the land of Nod, the genetic trait of slobbering randomly appears in 25% of little goblins in which female does not carry the slobbering gene. Okay, so we got to identify the what our two variables are, and it looks like to me that our two variables are mom with gene, mom's genetics. Looks like one variable has a slobbering gene, and I just put SG for slobbering gene or NSG for no slobbering gene. And little goblin, slobbering gene, no slobbering gene. Okay, so we have three numbers. We marked them, and we need to determine which one of those is only one variable. So let's look at this first one. First one says 95% of the little goblins carry the gene if the biological mother. That keyword if and biological mother tells me that that one has two variables because the little goblin carries it and the biological mother carries it. When I come up to the next one, it says 85% of adult females carry the slobbering gene in the land of Nod. That says nothing about the little kid or the little goblin. Since it doesn't, it's like, you know what? That's my answer. So I'm going to write that 85% right here. So this is going to be 0.85 or 85 divided by 100. Make sure my lights don't turn off anytime in the near future. And since I know that value, I know I can go ahead and write 1. And this is going to be 1 minus 0.85, which gives me a big 0.15 right there. Right away, I can bring those numbers up. So this is going to be 0.85. And by the way, I need to write this small. These are my little numbers. And this is 85% of adults carry the goblin. So I'm going to say mom with gene. And then I'm going to put mom, no gene. Then this is going to be kid with gene. And then kid, no gene. So, and that's what we said. Mom, slobbering gene, no slobbering gene. And by the way, if you want to write SG, NSG, SG, NSG, that's fine. I'm just trying to be a little more specific. So we've taken care of this 85%, so we can mark it off. We're done with that. It says 95% of the goblets carry the slobbering gene if the biological mother carries the gene. Mom with gene, kid with gene, that's 0.95. Well, if that's 0.95, this is 1 minus 0.95. We're done with that number, so we can go ahead and multiply this out. And we have 0.85 parentheses 0.95. And we have 0.8075. And here we have 85 parentheses 1 minus 0.95. And we have, 0.85 parentheses 1 minus 0.95. And we get 0.0425. Let's check our workout. Let's add those two numbers together. And it adds up to 0.85, so chances are we did this right. Okay, we have one other number. In the Lananod, the genetic trait of slobbering randomly appears in 25% of the goblins, in which the parent does not. So kid with it, so this kid has it. Randomly appears in 25% of the goblins, of which the female does not carry. So not carry, kid, that's 0.25. So we're going to go ahead and write 0.25 here. And this will be 1 minus 0.25. So let's multiply those out. So 0.15 times 0.25 gives us 0.0375. And, oops, parenthesis 0.15, 1 minus 0.25 gives us 0.1125. Let's add those two values. Make sure that they add up to 0.15. They do, so that's probably good. Now, by adding straight across, we should be able to get our final column values. So we're going to go 0.8075 plus 0.0375, and we get 0.845. And then we add these two values, 0.0425 plus 0.1125, and we get 0.115. 0.155, 0.845 plus 0.155, and we get one whole right there. Okay, so this table checks out. Looks pretty good. We got one more problem. If probability of A is 0.55, probability of B is 0.42, and A intersects with Z, then what is A union B? So I need to use the general addition formula. And the general addition formula is essentially probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Well, in this case, the probability of A, they tell us, is 0.55. They tell us the probability of B is 0.42. And they tell us the probability of the intersection is 0.40. So all I'm doing is just plugging in the values. That's all I'm doing. So when we add these up, 0.55 plus 0.42 minus 0.4 gives me 0.57. So the probability of A union B equals 0.57. Okay, I hope this helps. I look forward to seeing you on the next one. Thanks for watching.